Alrighty, so for this video, we're going to go over section 1, parts A and C of exam number 4, which talks about antiderivatives. So for the first part right here, we have the integral of 4x to the power of 6 minus x to the power of 3 plus 1 over x minus 3e to the power of x dx. So in this problem, we're asked to find the antiderivative of this expression right here. So what we want to do, so what the antiderivative is just simply undoing the derivative of each respective term in this instance. So what we want to do is we want to start term by term and apply the integral accordingly. So for the first term, for example, we have 4x to the power of 6. So in this case, we're going to use the power rule, which has 4x to the power of 7 over 7, because when it comes to antiderivatives for a power rule, you are adding 1 to the exponent, and then underneath you're adding n plus 1. So this n represents the exponent right here. So it's basically like the power rule for derivatives, but you're just like doing it in reverse kind of way. And then over here, this term, we can rewrite it as x to the 3 over x, and then plus 1 over x. So in this case, the antiderivative of this, or this you could just simplify to x over 2. So the antiderivative of x to the power 2 would just be x to the power 3 over 3. And then the antiderivative of 1 to the x is ln of x. So that would just be ln of x right over here. And then now we're looking for the antiderivative of 3 times e to the x. So whenever it comes to any Euler number term, given that we looked at the derivatives prior, it has its own special derivative. So in the case of Euler's number to the power of x, is always going to be e to the x no matter what, the antiderivative. So in this case, the term will just remain the same. So it'll just be 3e to the power of x. So this expression right here should give you the final answer for the antiderivative in this expression. Now for C, right here we have the antiderivative of 2x times 4 minus 6x to the power of 5th, to the 5th power. So what we want to do first here, we want to use u sub. So we want to find the inside function and represented by u. So in this case, the inside function would be represented by 4 minus 6x. So just be 4 minus 6x. Now what we want to do is we want to find the derivative of this inside function, which it would just be, in this case, it would just be negative 6. Also, you want to make sure you don't forget your dx terms as well too at the end. And then we want to find what dx is. So dx in this case would just be d u over negative 6 equals dx. Now, why did we find dx? We found dx in this case because we want to use it later on when we evaluate the expression. We want to substitute it for dx in order to enable us to like simplify the expression and find the answer more accurately in that case. What we also want to do is, since we have we're going to have two variables, so we're going to have x here and we're going to have u here. So let me just write that real quick. So we're going to have 2x, then u to the power of 5th. So dx, so we already have dx, so it's going to be du over negative 6. So in this case, when it comes to u subs and when it comes to antiderivatives, we cannot have two different variables in the same expression. So in that case, what we want to do over here we want to solve for x in terms of u, in order for us to be able to substitute and have the same variable in order to make it easier for us to solve. So in this case, we just take this expression right here and solve it in terms of x. So we would have u minus 4 equals negative 6x divided by negative 6. So that would just give you u minus 4 over negative 6 equals x. But since we have this expression right here, we can simplify it even further into a bit of a simpler formation. So in this case, we split it into two fractions essentially. So we'd have u over negative 6 minus, or plus I should say, because you have negative 4 over negative 6, which naturally just simplifies itself to 2 over 3. So x would just equal this expression right here. So now what we want to do is, since we have this integral expression right here, we want to simplify what we can. So in this case, 2 and negative 6 are going to cancel out, or not cancel out, but we're going to simplify even down. So you'd have the integral of x or sorry, in this case I should say you're going to have negative 1 over 3 x times u to the 5th du. So this is what we have right now in terms of the antiderivative, but since negative 1/3 is a constant, we can just simply take it, write it out of the integral, so we'll just do that. So we'll just do negative 1/3 times the integral of x u to the 5th du. And since we have x defined right here in terms of u, we could just simply write it as negative 1/3 the antiderivative of u over negative 6 plus 2/3 times u to the 5th du. I'll make sure you don't have to forget that. And now we have everything written in terms of u, so we want to apply the antiderivative rules. So in this case, or actually, instead of applying first, you want to make sure that you distribute evenly so that you have the final integral expression, and then we apply the antiderivative rules. So simplifying it even further, or distributing it even further, we'd have negative 1/3 times the integral of u to the 6 over negative 6 plus 2u to the 5th over 3 du. So this will be essentially our final integral expression that we can then, for which we can then use the antiderivatives in order to evaluate this accordingly. So in this case, we have negative 1/3. We want to write a big parentheses in order to indicate that these are two separate terms, and therefore we want to multiply them. So applying the power rule, so we have u to the power of 6 over negative 6. So in that case, it would just become u to the power of 7, because using the power rule, you're adding 1 to the exponent, and then times 7, or times, yeah, it would just be 7 in this case, because we have the new exponent, so which is going to end up being in the denominator spot. So in this case, given that we have already have negative 6, we want to multiply that by 7, which will give us negative 42. And then for the other term, right here we have 2u to the 5th over 3. So now, using the power rule again, we're going to have 2u to the 6 over 6 times 3, because we have the new exponent, which is going to be 6, which is going to be the new value in the denominator. And given that we already have 3 there, so we're just going to have to multiply these two together. So it's going to be 6 times 3, which is 18. And we have another big parenthesis right here. So this, now we can distribute the negative 1/3 into each term. So in this case, it would just be negative, or this case would just be positive, because you have because this fraction is negative, so it would just be u to the 7 over 42 times 3, which is 126, minus 2u to the 6 over 54. Now here you can just you simplify this term, so 2 divided by 54, or it would just be 1 over 27, so this would just equal u to the 7, 126, minus u to the 6 over 27. So now finally, given that this is u sub, we want to substitute the u value that we have here into the final expression that we have. So in this case, we would just have 4 minus 6x to the power 7 over 126 minus 4 minus 6x to the power 6 over 27. So this right here should give us the final answer for this problem. Thank you.